Welcome to the Kick training video on selective solder profiling. In this lesson, it is assumed that you are already familiar with the Kick profiling software and profiling. If you're not already familiar with the Kick profiling software and profiling, please see the Kick training video series titled Basics of Profiling. In this Kick training video on selective soldering, we will learn the following: understanding your selective solder machine, configuring your Kick software for selective soldering, running a selective solder profile, downloading and reviewing your selective solder profile, and last, optimizing your selective solder profile. In order to correctly configure your selective solder profile in the Kick software, you have to understand some of the basic hardware components of your selective solder machine. There can be many different configurations of selective solder hardware components, and this training video will not reference all of them. Some selective solder hardware designs will not lend themselves to pass or carry the profiler behind or close to the profile board. In some cases, the profiler may have to be held by an operator during profiling, and in others, the selective solder machine may not lend itself to be profiled at all due to physical constraints or safety reasons. Let's start the evaluation where the process starts and stops. Observe the selective solder process before you begin profiling to determine how the process flows from start to finish, and also to configure the software and hardware to correctly record the selective solder process. Note: normally, temperatures and fluxer sections of the selective solder will not affect the preheat temperatures. You may choose to start your profile data collection at the beginning of the preheat and not the beginning of the fluxer section. It is important to note that the Kick software logic only recognizes continuous conveyors when using predefined solder profile applications, such as wave, reflow, or cure. This training video will be showing you the only practical way to profile the selective solder process with the Kick profiling software, which is the temperature versus time profile application. Most, if not all, selective solder machines will not convey the product continuously or uninterrupted all the way through the selective solder process. At some point, the board will stop at the solder pot area for selective wave soldering. In some selective solder machines, the board may come to a stop at more than one point during the process. Therefore, we cannot enter a conveyor speed in the Kick software as we normally would with a true continuous conveyor speed application. Record your selective solder cycle time for future software configuration. Now that you have a better understanding of your selective solder machine, open Profiling Software 2G, connect your profiler, and select Run a Profile from the main menu. Start by typing your product name. You can now select the System Default for Reflow process window and apply a new wave solder process spec to this profile after it is completed. As mentioned previously in this video, select the application temperature versus time. Note: the AirTC is not required when using the temperature versus time application. Channel number 1 can now be used for standard product data collection. Next, select your sample rate. Kick recommends a sample rate of 10 readings per second. This will ensure a better profile accuracy when the solder nozzle contacts the PCB, since during this short period of time the temperature may present larger deviations. In the oven name field, type a name for the selective solder machine and continue. Note: using the temperature versus time application, you will see that there are no machine configurations such as conveyor speed and heated zone. Now select the thermocouples that you wish to use for your selective solder thermal profile. In this window, you should be able to confirm that you are seeing live readings from all the selected thermocouples. If you choose to add labels to your TCs, please check the Include Thermocouple Labels box on the top left and proceed accordingly. Check your profiler's internal temperature and battery voltage. Enter the expected profile length value in minutes according with the selective solder cycle time you identified at the beginning of this video. Kick recommends to add 30 seconds more to the profile length to ensure the profile does not end too soon. Note: the profiler will stop collecting data as soon as the user stops the profile or if the expected profile time is achieved. If no errors are indicated, click on the traffic light to start your profile. When you are running a selective solder profile using temperature versus time, please ignore this message and disconnect your profiler from the USB cable and insert it into the thermal shield if necessary. Click OK to proceed. Now put the profiler and profile board into the selective solder machine. Please make sure to use a thermal shield if necessary. In this video, we are displaying one example of profiling a selective solder process in a selective solder machine. Your machine may be different than this example and present different challenges with handling the profiler. It is important to carefully verify that there are no mechanical or other interferences to prevent you from profiling your selective solder process. On this video, you will see the profiler being carried on the same board pallet as the profiling board. You can see the profiling board and profiler being conveyed through the complete solder process. Your profile will be complete after the profiling board passes through the preheating and wave solder sections of the selective solder process. Once the profiler and profiling boards exits the selective solder process, reconnect the profiler to the PC using a USB cable and download your profile data. Once you have reconnected the profiler to the PC via USB cable, click on the stop icon to manually stop the profile. Note, look in the lower left corner of the Kick software to observe the data download status. After completing the profile data download, you should see the profile data plotted on the profile graph. Once the profile data has been correctly downloaded and plotted on the profile graph, the first thing we would like you to observe is the different thermal behaviors along the profile. You will see three sections: the fluxer section, the preheat section, and the wave or solder nozzle section. Using the temperature versus time application, the software does not have the capability to differentiate these three sections automatically, so it's necessary to visualize this separation in your analysis of the profile data. As mentioned earlier in this video, temperatures and fluxer sections do not affect the product temperatures. If you choose to start your profile data collection at the beginning of the preheat and not the beginning of the fluxer section, then this thermal data section would not be collected. Next, let's focus on the preheat area. It is possible to analyze the data and recognize the number of preheat zones that your selective solder machine has. This can be clearly visible in some selective solder machines and harder to differentiate in some others. A good evaluation of your selective soldering process is important to be able to have a good perception of the different preheater influence on the profile data. Note, if you cannot clearly differentiate the various preheat zones using the product thermocouples on the PCB, you could use an AirTC with no process specifications applied to clearly show the various zone separations. Next, we will focus on the solder pot section of the profile graph. Notice, it is possible to analyze when the product thermocouple passes through the wave nozzle. Note the temperatures in this area rise and fall in a shorter period of time. A good specification to verify the nozzle contact with the component or TC is the peak temperature. This can be individually defined per thermocouple. Note, the thermocouple attachment location will impact the thermal behavior, based on if the thermocouple is attached to the top or bottom side of the PCB. Note, if you are profiling a product that you already consider to be in spec or with good solderability, and you are just looking to ensure a stable process and repeatability over time, you may choose to edit your process specs for this product for an in-spec product specification. In this example, we will apply a specification for peak temperature, time above temperature, and preheat with a specification centered on the results obtained in this profile. You will be able to verify the machine stability with your own process specifications for future profiles. You can apply these same specifications to easily ensure you are maintaining good specifications through the overall PWI value. If you are looking to readjust or optimize your thermal profile, the correct identification of each thermal profile section is crucial in order to decide where and how much to adjust the machine recipe. Verify your selective solder machine recipe to have a better understanding. Let's start by focusing on the preheat zones. In the selective solder machine example, it's possible to modify the temperature set point, the time the board pallets stop in the two preheating zones, and other set points. The modification of the set points will create an impact in the time duration that the board is heated up on each preheat zone, as well as the ratio of heat transfer to the board. Increase or decrease set points accordingly with your optimization goals. Note: other selective solder machines will present different heated zone source types, different parameters to be adjusted, or different conveyor systems, and all those different parameters may impact the thermal profile in numerous ways. A good analysis and understanding of your machine will help to achieve your thermal profile optimization easier and faster. Next, let's proceed with the wave solder or solder pot evaluation. In this selective solder machine example, it's possible to modify the wave solder temperature, time that the board is being in contact with the wave solder, the wave height, and other parameters. To make sure the board is properly being soldered and achieving the right amount of temperature, these parameters may be changed. Note: it's important to verify and ensure the correct maintenance of the wave solder or nozzle pot mechanical parts. An incorrect wave flow behavior may impact the thermal profile results. This concludes the evaluation and optimization of your selective solder profile. Thank you for watching this video. If you would like more information on our products or have any questions, please go to our website, kickthermal.com. Thank you, and we appreciate your business.